Here's question number 5 from 2024. Consider the curve defined by that equation, and it can be shown if you take the derivative, it would equal that. So there is a point on the curve 2, 4 with the x-coordinate 3. Use the line tangent to the curve 2, 4 to approximate what the y-coordinate is at 3. So I want to do a tangent line here. So we have 3 values we're looking at, which is the x-coordinate, the y-coordinate, and the slope. So the x-coordinate and the y-coordinate are 2 and 4. To find the slope, we use the derivative, and we're going to plug in 2 for x and plug in 4 for y, and then answer it. And then our equation is going to be the slope, and then x minus 2 plus 4. To estimate it at 3, we're just going to plug 3 in, and I have our answer. That's all you need to do. So can you find the slope? Write the line, plug in 3. That could be 2 or 3 points right there. Part B. Is the horizontal line y equal 1 tangent to the curve? And give a reason for your answer. So the line y equals 1 is horizontal. And if that's tangent to the curve, a horizontal line, that means it's a turning point, meaning it's a critical point. So if I look at the derivative, the critical values would be what makes it 0. So there's my slope. If I plugged in, would it make it 0 in terms of what I'm looking for, both the x and the y? So if I look at the original equation, and if I plug in and there's 2 ways to go about it. The easiest way is here. I can tell that what makes it 0 for x is if x equals 0, negative 2 times 0 and divide would make a critical value. And the other one is if y. So if I plug in 0 for x, I'm left with 3y plus 2y squared equals 48. And then if I solve that, so first I'm going to rearrange it and subtract 48. I'm going to, if I try to solve for y, oh, did I write it down wrong? 2y squared. Let's see. So if I factor this, so 2 times negative 48 and 3, what 2 numbers here? 18 and 5? No. See if it's factorable. There's another way to go about it. So the other way to understand, so one is if x is 0, then what is y equal to make it 0? So what would be the other way in terms of understanding it? So if I solve this, if I look, if y equaled 1, let's do it that way. So if y equaled 1, so if you went 2, 1 squared plus 3 times 1 minus 48, I want you to notice that doesn't equal 0. So if x is 0 and if y is 1, it should give you a critical value, right, in terms of what it is. So when I plug in 1, it does not work or fit. Left side does not equal right side. So therefore, y equals 1 is not tangent. So I recognized it's a critical value. When x equals 0, you have a critical value. I plug that in for x. If I plug in 1 for y, left side should equal right side. If it's tangent, it is not, so therefore it is not tangent. Part C. The curve intersects the x-axis at this point, in root 48 and 0. Is the line tangent to the curve at this point vertical? And give a reason for your answer. So for there to be a vertical tangent, it would make the slope undefined. So here I have the slope. What would make this slope undefined is if this was equal to 0, the denominator. That would make it undefined, which would be a vertical tangent. So if I solve this, I would see the only value for y that would make it vertical is negative 3/4. And so therefore root 48 and 0, this does not match. Here the y coordinate is 0. Here, in order for there to be a vertical line, the y coordinate would need to be negative 3/4. So the answer to this would be no. Root 48, 0 does not make a vertical line or vertical tangent. These are kind of awkward questions, right? And it's going to be okay. So we still try our best. Part A was simple. B and C were a little more awkward in terms of understanding it. Let's look at Part D in terms of how to answer it. So Part D, you're given an equation y cubed plus 2xy equals 24. And it says the instant the point 42, the y coordinate of the particle's position is decreasing at a rate of 2 units per second. At that instant, what is the rate of change of the x coordinate with respect to time? So we have an equation that we need to take the derivative with respect to time. So the derivative of y cubed is 3y squared, but it needs the hook dy by dt because that hook is with respect to time. Here we have product rule. So that's the first times the derivative of the second, and we need the hook. And again, the derivative of y, we need the hook dy by dt, plus the second times the derivative of the first, and again, we need the hook for x, which is dx by dt, and then the derivative of 24, which is 0. In the question, it says x is equal to 4, y is equal to 2, and the rate we know is the y coordinate rate. So dy by dt we know it's decreasing by 2, so that means it's a negative value. And what we're looking for is dx by dt. So I'm going to plug in. So the y coordinate is 2, dy by dt is negative 2, x is 4, dy by dt again is negative 2, y is 2, and we're looking for dx by dt. And I'm going to solve it. So 2 squared times 3, that's 4 times 3 is 12, that's negative 24. This is 8 times negative 2, that's negative 16. And then here we have 2 times 2, that's 4. So adding this up, that's negative 40. So I'm going to add it to the other side. So that's negative 40. Add, so now it's 40. Divide by 4, and you have your answer. So the rate of change, oh, that's it. Is that an x? This is an x. Let me just make sure I change my letters here. My x's and y's start to look the same. All right. So dy, this is an x. So there's an x. That's an x. That's an x. Divide by 4. So the x coordinate is changing. It's increasing at this rate of 10. All right, that was it. Last question. Mr. G Math, over and out. Until next time.